Okay, so in this lesson, like the last lesson, we're going to look at multiplying binomials again. But with this lesson, you're going to find some shortcuts, and it's going to make things a lot quicker. So when I say special polynomials, those are going to be where you can do some shortcuts. So just to show you, and let's take a look, x plus 3 quantity squared. Remember last lesson I said you cannot just distribute this. You can't do that because there's an addition sign or subtraction sign in here. If it's all multiplication in there, then you can distribute, but because it's not multiplication, you can't distribute that. You have to rewrite it as x plus 3 times x plus 3. And after you rewrite it, then you need to do your double distributive. Okay? So x times x gives me x squared. X times 3 is 3x. 3 times x is 3x again. And 3 times 3 is 9. Okay, and then I can combine like terms. So you get x squared plus 6x plus 9. Okay? And then x plus 4 squared. So x plus 4 times x plus 4. So I get x times x is x squared. X times 4 is 4x, and then another 4 times x is another 4x, so we get 8x. And then 4 times 4 is 16. And then x plus 5 times x plus 5. So x times x gives us x squared. X times 5 and 5 times x. So that's 5x and then another 5x. So we get 10x. And then 5 times 5 is 25. Okay, so you can see, is there a pattern or is there a shortcut when we square a binomial? So if we had x plus 3 quantity squared, we got x squared plus x plus 9. X plus 4 quantity squared, x squared plus 8x plus 16. X plus 5 quantity squared, x squared plus 10x plus 25. You should start to see a pattern there. And if you see it, okay, notice if I talk about this first term as term A and the second term as term B, okay, it's just meaning first term and second term here. We can say when we square a binomial, we're going to get a squared plus, well, how do I get 10? I have to double the 5 and multiply it by x. So I'm going to say 2 times x times 5. So 2 times a times b. I'm doubling the first term, basically. And then I square the last term to get 25, or square 4 to get 16, and square 3 to get the 9. So then I say plus b squared. And that is our pattern that we're going to see. Okay? So here we go. A squared plus 2ab plus b squared. Or if there's a subtraction sign here, okay, subtraction, then it's going to be a squared still. But instead of plus 2ab, it's minus 2ab, and then plus b squared. Okay? So if we use the pattern as a shortcut, this can go a lot quicker. So a squared, that's our first term. This is a, this is b. Okay? So a squared, that's x squared. And then 2 times a times b. So 2 times x is 2x times b, which is 8. So that's 2x times 8 is 16x. And then square b, 8 squared is 64. So we get x squared plus 16x plus 64. Okay? And then it's the same thing with subtraction, except we're going to subtract our second term instead of adding. Okay, so notice that difference there. And that's because of subtraction inside of the parentheses. So now if we square a, our first term, we get n squared, and then 2 times a times b. So 2 times n times 7 is 14n, and then b squared is 7, so 7 times 7 is 49. So now we're going to end up with n squared minus 14n plus 49. And that's the shortcut if you want to use that. It makes multiplying a lot quicker. Okay? Now we're going to look at the product of a sum and a difference. So one of them is addition, the other one is subtraction, but the terms are the same. It's x and 3, just one with addition, one with subtraction. Okay, so we're going to distribute, double distribute, so we get x squared, and then x times negative 3 is negative 3x. 3 times x is positive 3x. And 3 times negative 3 is negative 9. Okay, so if we combine like terms, we end up with x squared minus 9, because the x's cancel each other out. Negative 3 plus 3 is 0. Okay, the next one, x times x is x squared. X times negative 4 is negative 4x. And 4 times x is 4x. And then 4 times negative 4 is negative 16. Okay, so now we combine our like terms. We get x squared minus 16. So, from seeing the patterns in the first two, I'm guessing you should be able to figure out what the pattern will be here. Okay? Distribute, x times x is x squared. X times negative 5 is negative 5x. 5 times x is 5x. And 5 times negative 5 is negative 25. Combine our like terms, these cancel each other out, so you get x squared minus 25. Okay, so the pattern for this one is going to be a squared minus b squared. Simple as that. You square the first term, square the second term, and just make sure it's minus, or a subtraction sign between them. Okay? So, if we use our shortcut, here's a, here's b. A squared is x squared. B squared is 81. So we can do x squared minus 81. Okay? This is called a difference of two squares. Okay? That's what these are called. They're called the difference of two squares because if you look at it, difference means it's subtraction, which it is, and then two squares. This is a perfect square. This is a perfect square. There's a difference of two squares. Okay, so now a here, we square a. 3 squared is 9, and then x squared is x squared. And then 2 squared is 4. So now I have 9x squared minus 4. Is this still a difference of two squares? Yes, because this is perfect, this is perfect. 9 is perfect, x squared is perfect, and 4 is perfect. It's a difference of two squares again. Okay? Anytime where we have the same thing here, it's going to give us a difference of two squares. Okay? So, which ones fit a special pattern and then which pattern? This one is going to be a squared plus 2ab plus b squared. Here's a difference of two squares, a squared minus b squared. This one is the same thing, so we have a squared plus 2ab plus b squared. This, because these are not the same binomial, then it does not fit a special pattern. So This one is no. This one, yes. Okay, that's our a squared minus 2ab plus b squared. This one is a cube, so no. This one, not the same numbers, so no. This one, not the same numbers. You cannot switch the negative. You can't switch them when you're subtracting. Okay, order matters when you subtract. If it was addition, it wouldn't matter, but because of subtraction, it does not work. Order matters. Okay, and then here, these are not the same number, so again, does not fit a pattern. If it doesn't fit, how do you multiply? Okay, you double distribute, like we did earlier. You can always double distribute. Okay, so a word problem. Square outdoor patio is surrounded by a brick walkway as shown. Suppose a brick walkway is 4 feet wide. What is the area? Okay, so here you have this brick walkway around this patio. Okay, they want to know what is the area of the walkway. Just this red walkway all around the patio. Okay, so in order to find that, you can do the total area of this large square, okay, and subtract the area of just the patio on the inside. Remember, area of a square is side squared. Okay, so I'm going to square the total area. The total area, okay, if I try to get one side here, the length from here to here, okay, if this length is x, now I want to get from all the way to this side to this side. I have 4 extra feet here and 4 extra feet here, so the full length is going to be x plus 8. And it's the same thing here. Okay? So we're going to, the total area is x plus 8 quantity squared minus the area of the patio. Well, that's x times x. Remember, side times side. So we get x squared. Okay, so now I need to multiply this to find the total area of the whole thing. So I'm going to use a shortcut because it's x plus 8 quantity squared. So a squared, that's first term squared, is x squared. And then plus 2ab, I can write it here, a squared plus 2ab plus b squared. So 2 times the first term, so that's 2x times the second term. 2x times 8 is 16x. And then square the second term, so 8 squared is 64 minus x squared. I combine any like terms, x squared cancel each other out. So now all I have left is 16x plus 64 feet squared. Okay? So when you're going to see word problems like this, think about how are you going to get just the area around the inside, or just the area of the sidewalk. You want to take the total area and subtract the patio area. Okay? That's it. Have a good night, and we'll talk about this tomorrow.